So let's start. So in the last class we have already discussed how to divide a complex number by another complex number, how to find multiplicative inverse of a complex number, and we have also learned how to find modulus of a complex number, how to find conjugate of a complex number, and also we have discussed in the last class this formula that if z is a complex number, if z is a complex number, one second, if z is a complex number, then z times z's conjugate, the complex number multiplied with its conjugate gives what? Square of its modulus, mod z square. Remember we discussed in the last class that z into z conjugate gives you what? Square of the modulus of the complex number
Good
z.
morning, sir.
Okay, good morning. Okay. So for example, suppose I give you a complex number z is equal to 2 plus 3i, and I want you to multiply the complex number z with its conjugate. You will get what? Square of the modulus of that complex number. Now what is the modulus of z here? How do we find modulus of a complex number? Square root of sum of the squares of the real part and imaginary part, right? What is the real part of z here? 2. So 2 square
Sir,
plus what is the imaginary part here? 3.
sir, 3
3
square.
square. So 2 square plus 3 square root over is equal to mod of z. Okay. So this is what? 4 plus 9, 13, root 13. Then what is square of modulus of z? 13. Okay. So z
Sir,
into z
13.
conjugate is what? 13. Everybody got it now? Clear?
Yes,
Clear
sir.
or not? Hello. Okay.
Yes, sir.
Yes, sir.
Okay. Very good. Very good. So we have already discussed all these things in the last class. Okay. Just give me a second. Let me just do what? It will take me 1 minute only. The delay. Okay. Let's continue. We have already discussed how to divide one complex number by another complex number. We have discussed how to find multiplicative inverse or reciprocal of a complex number, and today we'll talk about properties, different properties of modulus of a complex number and different properties of conjugate of a complex number. Okay, so pay very close attention, and we will also do a couple of long questions. Okay, pay very close attention. Yes. I think we have already discussed this property in the last class, that z into z conjugate. Suppose there is a complex number z into its conjugate. A complex number z into its conjugate is equal to mod z square, right? We have already discussed this property. Okay. There are a couple of identities that you must remember. Couple of identity first. Let's just get them out of the way. Identities involving complex numbers. See, these identities involving complex numbers, they are very similar to the identities involving real numbers. For example, if z1 and z2 are two complex numbers, then bit 1 z1 plus z2 whole squared is equal to z1 squared plus z2 squared plus 2z1 into z2, just like we're doing in case of real numbers. Okay, a plus b whole squared is equal to a squared plus b squared plus 2ab. The same formula also applies to the complex numbers. I hope you get my point, right? And similarly, z1 minus z2 whole squared is equal to z1 squared plus z2 squared minus 2z1 times z2. Okay. Okay. So let's move on. Okay. Next part. The next one is z1 plus z2 whole cube. Okay. z1 plus z2 whole cube. Okay, I hope you remember the formula for a plus b whole cube, right? A cube plus b cube plus 3a square b plus 3ab square. Remember a plus b whole cube?
Yes, sir.
We learned in high
Yes, sir.
school. Okay.
Yes, sir.
The same formula also goes here. The same formula also goes here. Just treat it like A and treat it like B. A plus B whole cube. So the same formula goes here. That is Z1 cube plus Z2 cube. Sorry, cube plus 3 Z1 square Z2 plus 3 Z1 Z2 square. And do you know that there is another easier way to memorize this formula? See, a plus b whole cube, the formula a cube plus b cube plus 3a square b plus 3b 3ab square. It is a tad difficult to remember. It is a little bit difficult for our brain to register. But there is another easier way to memorize this formula. And what is that way? That is a cube plus b cube plus 3ab into a plus b. Very simple. A plus b whole cube is equal to a cube plus b cube plus 3ab into a plus b. As you can see, after applying distributive law over here, 3ab into a 3a square b plus 3ab into b 3ab square, you get the same result. Get my point so far? And it is a bit easier. Okay. So similarly here also you can do what? Z1 cube plus Z2 cube plus 3 Z1 Z2 whole into Z1 plus Z2. Get my point so far? Similarly, hello, get it?
Yes, sir.
Yes, sir. Yes, sir.
Similarly,
Yes, sir.
Z1 minus Z2 whole cube. Okay. Now you remember there was a formula a minus b whole cube. Well, the easier version of a minus b whole cube formula is a cube minus b cube minus 3ab into a minus b. Very simple. Just in place of plus, here everywhere there is minus. A cube minus b cube minus 3ab into a minus b. Now if you expand it, if you open it, if you expand it, what do you get? A cube minus b cube minus 3a square b, then minus minus plus 3ab square. Remember, this was the formula you have memorized. Okay, also you can use this. They are the same. Get my point so far? So here
Yes,
also
sir.
Z1 cube,
Yes, sir.
Z1 cube minus Z2 cube minus 3 Z1 Z2 into Z1 minus Z2, or you can also use this one, Z1 cube minus Z2 cube minus 3 Z1 square Z2 plus 3 Z1 Z2 square. Whichever way you use, whichever formula you use, but you have to memorize this formula at any cost. Okay, got my point so far? Okay.
Yes,
A
sir.
plus b whole cube, a minus b whole cube formula. Okay. And the next thing is, remember that which bit are we doing here? 5. Bit 5. Okay. You remember that you have learned for in case of real numbers, a squared minus b squared is equal to a plus b into a minus b. You learned it in high school. The same also,
Yes,
the
sir.
same also, yes, the same also applies to complex numbers. That is, if Z1 and Z2 are two complex numbers, then Z1 squared minus Z2 squared is nothing but Z1 plus Z2 times Z1 minus Z2. Get my point so far? Clear?
Yes, sir.
Yes, sir.
Yes, Yes, sir. sir.
Okay. Similarly, the other formulas also will apply here. The next formula that we have learned in high school, that is a plus b whole squared minus a minus b whole squared is equal to 4 times a times b, 4ab. The same formula also applies here, that if Z1 and Z2 are two complex numbers, then Z1 plus Z2 whole squared minus Z1 minus Z2 whole squared is equal to 4 Z1 into Z2. Okay, the same formula goes here also. Okay, so these are the identities that involving complex numbers, which are similar to the identities involving real numbers. So not very difficult to memorize. Uh, even you don't have to memorize, because already you know this formula for real numbers. So the same applies in case of complex numbers also. Okay, we have forgotten to write here 2z1 z2, 2z1 z2. Okay, z1 plus z2 whole square equal to z1 square plus z2 square plus 2z1 z2. Okay, it went up here. Okay, sorry. Then it is z1 square plus z2 square. Okay, now take the screenshot and we'll move on.
Done, sir.
Done? Okay. Now let's talk about the properties of conjugate and modulus of a complex number. Okay, so I hope all of you remember how to find the conjugate of a complex number. I give you a complex number. Suppose I give you z is equal to -2 -3i, and I want you to find the conjugate of the complex number. Conjugate of z denoted by z bar on top. Z bar. Conjugate of z is denoted by z bar. So how do we find the conjugate of a complex number? By simply reversing the sign of the imaginary part. Okay, do not touch the real part, keep the real part as it is. The real part of the complex number is -2, keep it as it is. Simply reverse the sign of the imaginary part, and here the imaginary
So
part
plus
of this
3i.
complex, yes, here the imaginary part of this complex number is what? -3. It's -3. Remember, the standard form of the complex number is a plus ib, plus, there is plus in between. Whatever real number is multiplied with I, that is your what? That is your imaginary part, and there should be a plus in between. So if I write it like -2, there is -3i, I can write it as plus -3 into I. Now you see this is exactly the standard form. There is a plus in between. So whatever real number that is multiplied with I, which is -3 in this case, that is the imaginary part of the complex number. Now if I want to find the conjugate of the complex number, what do? I simply reverse the sign of the imaginary part. Here the imaginary part is -3, I make it +3. I make it what? +3. So +3i. So this is the conjugate of this, right? Not very difficult. You just have to reverse the sign of the imaginary part. So it was -3i, I made it +3i. Similarly, if I have a complex number, say 2 plus 3i, what will be its conjugate? 2 minus 3i.
So 2 minus 3i.
Okay, you just have to reverse the sign of the imaginary part, or the yes, you just have to reverse the sign of the imaginary part. Are we clear on this? Hello.
Yes, sir.
Yes, sir. Sir.
Oh.
Yes, sir.
Now let's talk about properties of conjugate of a complex number. Properties of conjugate. Properties of conjugate of a complex number. You see, if first property, if z is a complex number, then conjugate of z is the same as z itself. If I take conjugate of a complex number twice, I will get the complex number itself. Z conjugate is equal to z itself. Very simply we can prove it. Okay, it's not that difficult to understand also. Very simply you can prove it. You see, example, suppose I take a complex number z. Let's say it is a plus ib. Now you tell me what will be its conjugate? A minus ib. Remember, do not touch the real part, just reverse the sign of the imaginary part. That's how you get the conjugate of a complex number. Now do you remember that conjugate of a complex number is also another complex number? Conjugate of a complex number is also another complex number. Here z conjugate is also a complex number. Now if I want to find the conjugate of this complex number, that is conjugate of z, if I want to find the conjugate of z itself, then that means I want to find the conjugate of a minus b. I want to find the conjugate of a minus b. Well, what is the conjugate of a minus b? Isn't it a plus b? A plus ib? A plus ib? Isn't it same as z itself? Do you see? So conjugate of conjugate z equal to z. Got my point so far? Clear? Are we clear on this?
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
So suppose I ask you this question. If z is equal to 1 plus 2i, then find conjugate of z. So directly you can write what? This is the same as what? Z itself. You get it? Okay. Now if I ask you to find, suppose z is equal to 1 plus 2i, and I want you to find conjugate of conjugate of conjugate of z, 3 times conjugate. Now think on it. Well, conjugate of z is what? Z itself, right? It is z itself. Now there is another conjugate on top of it. You get my point so far? Clear? Hello?
Yes,
Hello.
sir. Yes, sir.
And if z is 1 plus 2i, what is conjugate? Isn't it 1 minus 2i? Get my point? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Why is everybody so sad? Huh? Why? Why? Pandemic or what? Pandemic is getting to you or what? Hmm?
No, sir.
Then
No,
why are you
sir.
so sad? Why are you so sad in the morning? Okay, morning time, don't be sad, be happy, be cool, relaxed. Okay, be casual, be happy, cool. Huh? Okay. Second property, z1 plus z2. Suppose z1 and z2 are two complex numbers. We add z1 and z2 and take its conjugate. First we add z1 and z2, whatever comes out we take its conjugate. It is the same as finding the sum of the individual conjugates of the complex numbers. Get my point so far? z1 plus z2 whole conjugate is the same as z1 conjugate plus z2 conjugate. Okay, not that difficult to memorize. Got my point so far?
Yes, sir. Yes, sir.
Similarly, if z1 and z2 are two complex numbers, then z1 minus z2 whole conjugate is equal to z1 conjugate minus z2 conjugate. And remember, this does not just apply to only two complex numbers. No, this applies to any number of complex numbers. This applies to any number of complex numbers. For example, z1 plus z2 plus z3 plus dot 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 dot. There are some complex numbers and we add them and find their conjugate. This is same as z1 conjugate plus z2 conjugate plus z3 conjugate plus dot 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 dot. Doesn't just apply to only two complex numbers, it can apply to any two complex numbers. Similarly, here also in this case, z1 minus z2 minus z3 minus z4 conjugate is equal to z1 conjugate minus z2 conjugate minus z3 conjugate. I hope you get it, right? Okay.
Yes, sir.
Now,
Yes, sir.
Now let's talk about the next property. Next property is if z1 and z2 are two complex numbers and first we multiply them, then find their conjugate. This is the same as the product of their individual conjugates. I hope you get my point. Clear? Okay. And
Yes, sir.
similarly this also doesn't just apply to only two complex numbers. If it were any number of complex numbers, z1 into z2 into z3 into dot 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 dot, if there were any number of complex numbers and we multiply them, then find that conjugate, it is the same as multiplying their individual conjugates. Clear? Okay. Now, what is the last property that we are going to study is if z1 and z2 are two complex numbers, then z1 divided by z2 is another complex number. Remember, if z1 is a complex number, z2 is a complex number, you divide one complex number by another non-zero complex number. Remember, here z2 is not equal to 0, because you know that if the denominator is equal to 0, then the fraction itself collapses. It becomes undefined. The fraction doesn't make any sense if the denominator is equal to 0. Just like in case of real numbers, you cannot divide any real number by 0. Denominator of a fraction can never be equal to 0. Okay, so we know that if we divide one complex number by another non-zero complex number, in return we also get another complex number. z1 by z2 is also a complex number. Now, one second guys, one second. Okay. Bas, let's continue. Okay. So if z1 and z2 are two complex numbers and z2 is not equal to 0, then we divide z1 by z2, we get what? Another complex number, right? And if we take its conjugate, if we take the conjugate of the division of two complex numbers, this is the same as Z1 conjugate divided by Z2 conjugate. I hope you get it right. Clear? Okay.
Yes, sir.
Yes.
Yes, sir.
Yes,
Okay.
sir.
Very good. Very good. Take the screenshot. 1 second. Yes, take it. Take it. Done.
Yes, sir.
Yes, sir.
Take
Yeah,
it.
done.
Okay. And there is one last property that is not there in your book, but we are going to discuss that property. It's not there in your book, but it's very easy property, that if Z1, if Z is a complex number, suppose Z is a complex number, and you take its power, suppose n, then you see Z to the power n means what? You multiply the complex number n times, right? Z into Z into Z into Z. Just like 2 to the power 3 is what? 2 into 2 into 2. Multiply 2 3 times. So when Z to the power n is multiply Z n times. And then you take its conjugate. It is the same as, first you find the conjugate of the complex number, then you take its power n. This is the same. First you take the power n, then whatever you get, find its conjugate. It is the same as, first you find conjugate, then take the power n. I hope you get it, right? Take the screenshot. Are you done? Okay.
Yes, sir. Done.
Done, sir.
Take it. Done? Okay.
Yes, sir.
Now let's talk about properties of modulus of a complex number. Properties of modulus of a complex number. See, most properties of modulus of a complex number are closely similar to the properties of conjugate of a complex number. Okay, but there are two properties of conjugate of a complex number that do not hold in case of modulus of a complex number usually. I will tell you that, but mostly they are the same. Okay, the first property of modulus of a complex number: if Z1 and Z2 are two complex numbers, we multiply them, then we get another complex number, and if you take the modulus of their product, this is the same as taking the product of the modulus of the individual complex numbers. And also here, this doesn't just apply to only two complex numbers. You take any number of complex numbers, this formula holds. That is, if Z1, Z2, Z3, Z4 etc. are some complex numbers, then you multiply them, then find its modulus. This is the same as multiplying the individual moduli of all the complex numbers. I hope you get my point so far. Clear? Okay.
Yes, sir.
Now the second bit. If Z1 and Z2 are two complex numbers, and again if Z2 is not equal to 0, because you know that if denominator is equal to 0, then the entire fraction is meaningless. So Z1 by Z2 modulus, first divide Z1 by Z2, find its modulus. It is the same as dividing the modulus of the numerator by the modulus of the denominator. Now here, let me just write this down, note. Do you remember in case of conjugate of a complex number, we learned this formula, we learned this property, that Z1 plus Z2 conjugate is equal to Z1 conjugate plus Z2 conjugate, remember? And also we discussed that Z1 minus Z2 conjugate is the same as Z1 conjugate minus Z2 conjugate. Well, this kind of property does not hold in case of modulus of two complex numbers. Remember that Z1 plus Z2 mod is not the same as Z1 mod plus Z2 mod. Remember, okay? Okay, got it?
Yes, sir.
Similarly,
Yes, sir.
Z1 minus Z2 mod is not the same as Z1 mod minus Z2 mod. Okay, whatever is there syllabus, we are going along with that. We are not learning anything extra, we are not learning anything less also. Okay, a little bit where somewhere along the way we are learning anything extra, but otherwise everything that we are learning is in your syllabus. So you have to memorize them one by one. You have to memorize all the properties one by one. You cannot miss anything. Get my point so far? So take the screenshot. Take it. Done. Sorry,
Yes, sir,
sorry,
done.
sorry. There was something on top also. Yes. Take it. Done.
Yes, sir, done.
Okay, take it. What about Biswajit Pradhan? What
Done,
about Sital? What about Biswarika? What about the others? Why are you not responding? What about Bhumika? Why so sad? Why so sad? So early in the morning, huh? Why are you sad? And why are you not talking? You are not interested in studies or what? Hmm? And you are not interested in studies or what? Hello?
Yes, sir.
Are you are
Yes,
interested
sir.
in No. You are saying this just like just like I'm forcing you to say yes. You are interested in studies. You are not freely saying that we are sir. We are interested in studying. We are interested in science. Whatever you are doing, you are interested in it. Because let me tell you, if you are not interested in your studies, if you are half-heartedly studying, then you cannot succeed in your field. Get my point so far? So you have to show a little bit of enthusiasm. Got my point so far? Okay.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Now let's do a couple of 4 mark and 6 mark questions. For example, if I ask you to find the multiplicative inverse or reciprocal, I can ask you anything. I can ask you multiplicative inverse or I can ask you reciprocal. They are the same, not different. So find the multiplicative inverse or reciprocal of z is equal to let's say 2 minus 3i. So here we have a complex number z is equal to 2 minus 3i and we want to find its multiplicative inverse or its reciprocal. Okay, let's find the solution. Will you remember that multiplicative inverse mi, mi stands for multiplicative inverse or reciprocal, whatever. Multiplicative inverse of z is what? 1 by z, right? Remember? Or reciprocal 1 by z. Clear? Now
Sir.
here z is equal to 2 minus 3i given. Then we just have to find out 1 by z. We just have to find out 1 by z. Well, 1 by z is what? 1 by 2 minus 3i. And remember in the last class I told you this, that 1 divided by 2 minus 3i is also a complex number, because you know it that the real number 1 is also a complex number. Every real number is also a complex number. Every real number is also a complex number. It is called a purely real complex number. So 1 is a complex number, z is a complex number, and z is not equal to 0. So one complex number divided by another complex number is also another complex number. That means this is a complex number. 1 by 2 minus 3i is a complex number. But we cannot stop here. Even though this is a complex number, but it is right now not in its standard form. I get it that this is a complex number, but this is right now not in its standard form. And what is the standard form of a complex number? A plus ib, some real number plus I times another real number. This is called the standard form of a complex number. So anyhow you have to bring this into its standard form. And what is the trick to it? I told you that you can do it using the standard method or you can use the direct formula also. So let's just go along the standard way. See, my first target would be to get rid of the I on the denominator. You get my point? What my first target will be? To get rid of the I on the denominator. And in order to do that, I will always do what? I will multiply the conjugate of the denominator. What is the conjugate of 2 minus 3i? The conjugate of denominator is 2 minus 3i. What is conjugate?
So 2 plus 3i.
I will multiply the conjugate of the denominator on the top as well as on the bottom. Because if I just multiply on the denominator and leave the numerator as it is, then the fraction value will change. You know it in high school that suppose there is a fraction 3 by 5. If you are multiplying 2 on the denominator, you also have to multiply that 2 on the numerator, so that these 2 and 2 will cancel out and the fraction value doesn't change. Here also the same thing. If you are multiplying something on the denominator, you have to multiply the same thing on the numerator as well. So 2 plus 3i, 2 plus 3i. Always you have to do this. What do? You multiply the conjugate of the denominator on the top and on the bottom. Well, now the numerator is 2 plus 3i, and look at the denominator. Here you can apply direct formula, or also you can do a plus ib into a minus ib method. Well, let me show you. The direct formula is a plus ib into a minus ib is equal to a square plus b square. Remember, a square plus b square.
Yes, sir.
So here 2 minus 3i into 2 plus 3i, it is the same as 2 square plus 3 square. You get it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Also, if you get confused, then no worries. You can just use the properties. Do you remember x minus y into x plus y is equal to x squared minus y squared? That is 2 squared minus 3i squared. Here x is 2 and y is 3i. 2 squared is 4 minus 3 squared is 9 and I squared is what? Minus 1.
So minus 1.
Then this is 4 minus minus plus 9. We have also written the same, 4 plus 9. Okay, so anyway you can do this. Got my point so far? Clear? Okay.
Yes, sir.
Yes, sir.
Okay. Now what do we get? We get 2 plus 3i divided by 2 square is 4 plus 3 square is 9. 9 plus 4 is 13. Now can I write it as 2 by 13 plus 3 by 13 times I? Now this is in standard form. Okay.
Yes, sir.
We haven't made any changes to the complex number. The complex number 1 by z, we haven't made any changes to the complex number. 1 by 2 minus 3i, we haven't changed it at all. We just changed its form. We just made it, brought it to standard form. That's it. Got my point so far? So this is how you will find the multiplicative inverse of a complex number. So take the screenshot. Done? Got it?
Yes,
Done?
sir.
Yes,
Done, sir.
Okay. Well, there is a formula also. You can use direct the formula. We learned that 1 by z is the same as conjugate of z by square of the modulus of z. This is the formula that we have learned in the last class. So using this formula also you can do it. Z was given to be what? 2 minus 3i. What is conjugate of z? 2 plus 3i. Now let's find modulus of z. Modulus of z is what? Square root of real part square. What is the real part here? 2.
Sir, 2.
Plus imaginary part square. What is the imaginary part of z here? Minus 3. See, minus 3 square and 3 square, they are the same. You get my point so far? So
Yes,
4
Yes, sir.
Yes, sir.
plus 9 root 13. Then what is mod z square? If mod z is root 13, then mod z square is 13, right?
Yes, sir.
Okay, so we can directly apply the formula. Then 1 by z will be what? Conjugate of z, that is 2 plus 3i divided modulus of z square, which is 13. So is equal to 2 by 13 plus 3 by 13i. Take the screenshot. Alternative method. You can do whichever way suits you. Clear?
Yes, sir.
Done.
Okay. Okay. Now let's move on. Okay. There are some questions that from your book. Express the following in the form of a plus ib. Express the following in the form of a plus ib. Very simple. Suppose bit 1, it is given to be 5 plus root 2 into I divided by 1 minus root 2 into I, and we have to bring it. This is given to us, and the question is to express this, whatever this is, to express this in the form of a plus ib. Well, let's just analyze the question. Okay, let's just stop a bit and let's analyze the question. In the question, what is given here? This is a complex number, numerator is a complex number, denominator as you can see is also a complex number, and also denominator is not equal to 0. Denominator is not equal to 0. Numerator, denominator both are complex numbers. That means here it is asking you to divide one complex number by another complex number. As simple as that. Not a very new question. Get my point so far?
Yes, sir.
Yes, sir.
Yes, sir.
Now we know that if we divide one complex number by a non-zero complex number, if we divide one complex number by another complex number which is not equal to 0, then in result also we get another complex number. That is, this whole thing is a complex number. One complex number divided by another complex number, this whole thing is a complex number. But the problem is, this complex number is right now not in its standard form. Not in its standard form. And what is the standard form? A plus IB. A plus IB is the standard form. So in the question it is indirectly asking you to bring it to its standard form, or to bring it to the form of A plus IB, means to bring it to its standard form. Well, we will apply the same procedure here. The same procedure that we applied in case of multiplicative inverse. Well, our first target would be to get rid of the I on the denominator, right? I on the denominator is causing us all that trouble. So our first target is to get rid of the I on the denominator. And in order to do that, what shall we do? We'll multiply the conjugate of the denominator. We'll multiply the conjugate of the denominator on the top and on the bottom. What is the conjugate of 1 minus root 2i? 1 plus root 2i.
1 plus root 2i.
Yes. So we'll multiply that on the top as well as on the bottom. If we just multiply it on the bottom, then the fraction value will change. So to keep the fraction value constant or same, we'll have to multiply the same thing on the numerator. Okay. Now on the denominator, see, a plus ib into a minus ib, it is written, you see, a plus ib into a minus ib is equal to a square plus b square, direct formula. So 1 square plus root 2 square. See, you can also directly write 1 plus 2, doesn't matter. Okay, just have to write it correctly. Are you get my point so far? A square plus b square.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now on the numerator, what shall you do? You have to apply distributive law here. 5 into 1, 5, plus 5 into root 2i means 5 root 2i, plus root 2i into 1 is root 2i, plus root 2 into root 2 is 2, I into I is I square, which is minus 1, we know it, right? I square is minus 1. I just applied distributive law. So you see, this is 5 and I square is minus 1. We know that I square is minus 1. So 2i square becomes what? Minus 2, isn't it? So 5 minus 2. I will bring the real numbers together. This becomes minus 2. I brought the minus 2 close to 5. I brought all the real numbers together. And from these two, we will take I common. Well, no need to take common. We know that 5 root 2i plus root 2i will be what? 6 root 2i. I get my point. If you take I common, 5 root 2 plus root 2 is what?
So 6 root 2i. Yes, sir. Yes, sir.
Take root 2 common, 5 plus 1, 6 root 2. You get it? 6 root 2i.
Yes, sir.
Yes, sir.
Divided by 1 square is 1, root 2 square is 2, 2 plus 1 is 3. Well, what is this? This is 3 plus 6 root 2i divided by 3. That means 3 divided by 3, which is 1, plus 6 root 2 divided by 3, 2 root 2i. See, now it is in standard form or not? Done?
Yes, sir.
Yes, sir.
Okay. Okay, take the screenshot. Done?
Done, sir.
Yes, sir. Done.
Yes, sir. Done.
Okay. Okay. So now let's move on to the next question, and this is a long question. Okay, you have to be very careful about it. This is a long question, and before we discuss this long question, we'll first talk about equality between two complex numbers. I think we have already discussed equality between two complex numbers. I think so, right? If Z1 is equal to Z2, then their corresponding real parts are equal and their corresponding imaginary parts are equal. Have we discussed this or not?
Yes, sir.
Yes,
Still-
sir.
Okay, still let me just remind you. That let Z1 and Z2 be two complex number. Let Z1 is equal to A plus IB and Z2 is equal to C plus ID. Suppose they are two complex numbers. Then Z1 will be equal to Z2 if and only if their corresponding real parts are equal and their corresponding imaginary parts are equal. The real part of Z1 and the real part of Z2 must be equal. The imaginary part of Z1 and the imaginary part of Z2 must be equal, so that the two complex numbers will be equal to each other. Otherwise not. Get my point so far? Clear?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Okay. So using this equality concept of equality between two complex numbers, we'll do this question. This is a 6-mark question. Pay very close attention. If A plus IB is equal to x plus I, one second, yes, x plus I whole squared divided by 2x squared plus 1, then prove that a squared plus b squared is equal to x squared plus 1 whole squared divided by 2x squared plus 1 whole squared. Well, it is a very easy question, very easy question, not at all difficult. Okay, just have to understand the concept. Okay, how do we solve this? How do we approach this problem? Well, before we move on to solve this problem, I will actually tell you how to do it. How can you do it on your own? See, on the left hand side, whatever you have to prove, a square plus b square is equal to this thing. On the left hand side, what you have? A squared plus b squared, right? Now think about it. If somehow I can get the value of a and I can get the value of b, then will it not be easier for us to simply find a squared, then b squared, then add them? It's the basic concept, right? If we get the value of a, if we get the value of b, then we add their squares and we'll get the RHS. That's it, right? As simple as that. Get my point so far?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now the problem is how do we find the values of a and b? Well, you will use the equality concept, equality between two complex numbers, that concept. Okay, so let's see. It is given to us, it is given that a plus ib is equal to x plus I whole squared divided by 2x squared plus 1. Okay, let me just tell you one thing. It is given to us, and on the left hand side we have a complex number, and also on the right hand side we have another complex number, and it is given that these two complex numbers are equal to each other, right? This complex number is equal to this complex number, and we know that if two complex numbers are equal to each other, then their real parts must be the same and also their imaginary parts must be the same. The real part of the complex number on the left hand side, that is a, must be equal to the real part of the complex number on the left hand side. The imaginary part of the complex number on the left hand side, that is b, must be equal to the imaginary part of the complex number on the right hand side. But the problem is, still there is a problem. The problem is, on the right hand side, this complex number is not in its standard form. this complex number is not in a standard form. If you see closely, if you look closely, denominator there is no problem. On the denominator there is no problem. It is a real number given to us, 2x square plus 1. There is no I. But on the numerator there is a problem. It is actually given to you square of some complex number. So first of all you have to open the square. Get my point so far? A plus I
Yes,
is
sir.
equal to, this is x square plus I square plus 2xi. 2x square plus 1. Everybody getting my point? What I am trying to say?
Yes, sir.
Yes, sir.
Yes,
Then a
sir.
plus ib is equal to, well, we know that I square is minus 1, isn't it? This I square is minus 1. So this is what? X square minus 1 plus 2xi divided by 2x square plus 1. Well, we're almost done. Then a plus ib is equal to, remember what is the procedure? The real number x square minus 1 divided by this plus 2xi divided by this, right? This is how we separate the real part and the imaginary part in case of division. You get my point so far? Remember? Hello? This divided by this
Yes, sir.
plus this divided by
Yes,
this.
sir.
A plus b by c is equal to a by c plus b by c. As simple as that. You learned it in high school. Now, what do we have here? You see on the right hand side we have a complex number in its standard form right now, as you can see here. See, look here, isn't it a real number? X square minus 1 by 2x square plus 1. Is there any I? Is there any I in it? No, right? It is a real number,
No,
right?
sir.
Okay. Now see here, this one, isn't it also a real number? 2x by 2x square plus 1. Is there any I in a 2x by 2x square plus 1? No. It is a real number.
No,
So
sir.
you see it is in this form, a plus b I, isn't it? A plus b I. That means it is in standard form right now, right? Okay, think about it. If this complex number and these complex numbers are equal, then their real parts must be the same. That is, a must be equal to what? X square minus 1 by 2x square plus 1. Similarly, b must be equal to what? The imaginary part. Are you get my point so far?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
See, just like I told you, we have accomplished to find the value of a and b. Now simply the LHS is what? A square plus b square. So we'll just have to add the squares of these two. X square minus 1 whole square. A square is what? X square minus 1 whole square by 2x square plus 1 whole square. Plus what is b square? 2x square means 4x square. You get it? Whole square of 2x is 4x square. And then the denominator, what you get? What? 2x square plus 1 whole square. Clear or not? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now you see, you take the LCM, what?
Sir, 2x square plus 1.
Whole square. Okay. And on the numerator is x square minus 1 whole square plus 4x square. Because you see, you know that a by b plus c by b is equal to a plus c by b, isn't it? That's what I did. Okay. Now, on the numerator, if you think about it, if you open it, x square is x square minus 1 whole square. So a minus b whole square formula will apply here. A minus b whole square. A square plus b square minus 2ab. That is x to the power 4 plus 1 minus 2x square plus there is already a 4x square divided by 2x square plus 1 whole square. I hope you get it. Now
Yes, sir.
Yes,
this
sir.
is
Yes,
to
sir.
the power 4 plus 1. And what is 4x square minus 2x square? Isn't it plus 2x square? Okay. Now you tell me, isn't it x square plus 1 whole square? You tell me. X to the 4 plus 1 plus 2x square. You tell me.
Yes, sir.
So this is your RHS proved. Get it? Can you do it if it is asked? 6-mark question.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So take the screenshot. Done.
Yes, sir.
Okay.
Yes, sir. Done.
Okay. And we'll do one more question, which is also appropriate for a long question. The question from the book itself, it says that if Z1 modulus is equal to Z2 modulus is equal to Z3 modulus is equal to dot 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 is equal to Zn modulus. See, there are n number of complex numbers here. The first complex number whose modulus is equal to the modulus of the second complex number is equal to the modulus of the, in fact the modulus of all these complex numbers are equal, it says so, right? Equal dot 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 dot. Modulus of all these complex numbers are equal to 1. Modulus of all these complex numbers are equal to 1. Do you remember I told you this, that modulus of a complex number is a real number? Remember? And how do you find modulus of 1 plus 2i? What is modulus of 1 plus 2i? 1 square plus 2 square plus root over. Okay. Real part square plus imaginary part square. Got it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So it is given to us that modulus of all these complex numbers are equal to 1. Then prove that 1 upon Z1 plus 1 upon Z2 plus 1 upon Z3 plus dot 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 plus 1 upon Zn, its modulus is equal to the modulus of Z1 plus Z2 plus dot 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 plus Zn. Okay, we have to prove it. Everybody got the concept?
Yes,
sir.
Clear
sir.
now?
Yes, sir.
Okay. Okay. So you see, this is a very important question, and this is a very little bit tricky. Okay, little bit tricky, not difficult, but a little bit trickier than the problems that we have already solved. Okay. So let's just try to see how we can prove it. Now what is given to us, you tell me? Z1 mod is equal to Z2 mod is equal to Z3 mod is equal to mod of Zn is equal to 1, isn't it? It is given to us, right?
Yes, sir.
Yes, sir.
Then we know that square of this will be equal to square of this will be equal to square of this. If two numbers are equal to each other, then their squares must also be equal to each other, isn't it? If two numbers are equal to each other, then their squares must also be equal to each other. Will be equal to what? 1 square 1, right? That means the square of mod z, square of mod z2, square of mod z3, square of mod zn, they are all equal to 1. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Sorry, here there is z1. Okay. Now, do you remember a concept that we have already learned, that z into z conjugate is the same as mod z square? Do you remember this or not?
Yes,
That a
sir.
complex number times its conjugate is equal to modulus square. So z1 mod square is the same as z1 into its what? Conjugate. Z2 mod square is what? Z2 into its what? Conjugate. Z3 mod square is what? Z3 into what? Its conjugate. Are get it?
Yes,
Yes,
sir.
sir.
Yes, sir.
Z into Z conjugate. They are all equal to 1, right? Okay. Now, you see that Z1 into Z1 conjugate is equal to 1, isn't it? Because they are all equal to finally 1. So this is equal to 1. Then obviously, if I divide both sides by Z1, then Z1 conjugate is equal to 1 by Z1, isn't it?
Yes,
I got
sir.
it.
Yes,
Ah,
sir.
Yes.
sir.
Yes, but let me tell you one thing. You see that there is a problem that some of you do what? And you see this is not always equal. Z1 conjugate is Z conjugate is not equal to 1 by Z always. Hey, this is based on the condition that is given in the question. Based on this condition, if their modulus is equal to 1, then only this happens. This is a special case. Whenever modulus of a complex number is 1, then this happens. You don't always think that conjugate of Z is this. Okay, that's incorrect. Got my point so far? Based on this condition. Clear what I am saying?
Yes, sir.
Yes,
Hello.
sir.
Yes, sir.
Similarly, we can say that Z2 into Z2 conjugate is equal to 1. So similarly, we can prove that Z2 conjugate is here what? Equal to 1 by Z2. Okay. And similarly, we can say that Zn conjugate will be equal to what? 1 by Zn.
Sir, 1 by
Clear,
Z.
clear on this? Okay. Now let's come to our LHS. Hello, everybody clear on this so far?
Yes, sir.
Yes,
Yes,
sir.
sir.
So let's come to LHS. Now LHS says what? 1 by Z1, sorry, 1 by Z1 plus 1 by Z2 plus 1 by Z3 plus dot 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 plus 1 by Zn modulus, right? It was our LHS, and we know that here under the condition that is given to us, we have proven that 1 by Z1 is equal to Z1 conjugate under the condition that is given to us, right? 1 by Z2 is equal to Z2 conjugate. You get it? 1 by Z3 is equal to Z3 conjugate. Clear?
Yes, sir.
Yes, sir.
Conjugate.
Yes, sir.
Okay. Now, do you remember the properties of conjugate that we learned today itself? That any number of complex numbers I give you, add them and get the conjugate of the entire result is the same as the sum of the conjugate of the individual complex numbers. So here also Z1 conjugate plus Z2 conjugate plus Z3 conjugate plus Zn conjugate is the same as Z1 plus Z2 plus Z3 plus dot 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 plus Zn whole conjugate, isn't it? Are got it?
Yes, sir. Yes, sir. Got it.
Yes, sir.
Yes, sir.
Yes, sir.
Whole conjugate. Whole conjugate. Now, you see that Z1, Z2, Z3 up to Zn, they are complex numbers, and when you add them, you also get a complex number. You add some complex number and also you get a complex number. Closure law, remember? Adding two complex numbers, you get a complex number. Okay.
Yes, sir.
Do you remember that in the last class or the class before the last class we have discussed this, that modulus of a complex number is the same as, no, I think in the last class we have already discussed, modulus of a complex number is the same as modulus of its conjugate is the same as modulus of minus z is the same as modulus of minus z conjugate. We have discussed this in the last class, remember?
Yes, sir.
Yes, sir.
Okay, so but we do not need these two right now, we only need the first one, that modulus of a complex number is the same as that of its conjugate, it's same as the modulus of its conjugate. So here z1 plus dot 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 up to zn, this is a complex number, then its conjugate modulus is the same as modulus of the complex number itself. You get it? Modulus of this is the same as modulus of the conjugate of this. You get it? This is your z. Hello, get it?
Yes,
Yes,
sir.
Yes,
This is
sir.
your z. Modulus of z is the same as modulus of your conjugate. Okay. So proved. This was your RHS. You proved it. So take the screenshot. Take it.
Done, sir.
Done.
Yes, sir. Done.
Can you take it? Done.
Done, sir.
Okay. Take it.
Done, sir.
Done.
Yes, sir. Done.
Okay. Now you tell
Done,
me
sir.
now you tell me when your classes end today. What is the last? What is the class? What is the time of the last class of yours?